Yes, today we are starting with the class on Python tokens and basic controls. Let us see whether we would be able to have enough of Python in 4 weeks. If we do, then we either go back to once a week lecture, or if we find it convenient, we can continue in the 2 weeks, but we will 2 lectures a week, but we will spend most of the time on graphics rather than on Python. And by that time, our Python should have taken root, and it will be an environment for instructing in drawing. I'm not interested in Python that much, but I'm interested in the fact that when you know Python, there are certain things that I see being taught on the web. I just laugh. They are not being well taught at all. If the best thing is for somebody to know how to program and to do repetitive things by writing code, not by mechanically doing some things. But let's go on. You will see how it goes as we move on. So today we talk about Python tokens and basic controls. The strategy for instructing the basics. Today essentially marks our first day in this programming class. Previously, we've been trying to get the environment ready. I hope everybody listening to me now has already installed new code. The environment is working. If you have not done that, better leave now and go and do that, because if you don't have a Python set working, you are wasting your time. The number 4 thing I talked about here, which is mathematical. I am no longer promoting mathematical. I'm now promoting Sage Math. I will talk about that later on. And Sage Math is completely free. So it is, in that sense, more useful to us than mathematical. In another sense, it is more useful because it is done in Python using the Jupyter Notebook. So you don't need to learn another language like you would have had to do if you are doing mathematical. There is a wonderful book from which I learned Fortran in 1980. The title of the book is Programming Proverbs in Fortran by Henry F. Legard. Now, I've got a copy of that book again. So even though in today's class, I'm going to use only proverb number 1, I will take a look at it and see whether I can use the other proverbs as I teach this class. Today's class is built on proverb number 1. I hope to get a book as soon as I can. I have already got a book. And so we'll talk about that one later on. The rule number 1 is that you master the rules first and then break them to become a master. That's program number 1. If you start breaking the rules without mastering them, you're a fool. Shouldn't be a fool. Know the rules before you break them, because when you know them, then you can see whether breaking them makes your situation better or not. But if you don't know the rules and you are breaking them, then you are behaving like an ignorable. So for this class, whatever rules I'm going to give you, master them well. If my programming is not good, don't worry. Just go ahead and understand them. By the time you get to a point where you can say that you can do better than I am programming, that's a good sign. That shows you are learning something. So there's no problem with me. Strategy for instruction. Today's class will set forth some rules in programming Python. You will know how a Python code is set up in the programming tokens, each with specific rules of usage. I will introduce programming tokens, and you will know what laws govern their usage. I will illustrate this by the simplest codes that a primary school child can use. I bring the matter so low to the level of sets and collections, which is very elementary principle. In fact, a high percentage of this lecture comes from classes I gave to secondary school students. The examples are simple, deliberate, and will not stress you. There is no hard example here. Every example is at secondary school level. A foolish student will see them as too simple and may not pay sufficient attention. In order for me to be sure that I'm carrying most of you along, I will spend considerable time reminding you of certain issues in set theory, which you did in secondary school or in your first year. Set theory is so basic and so elementary. I can teach it to any primary school child. When you talk of set, you are just talking of a collection. That's all. There is nothing. Everybody knows how to collect things. You can collect pebbles, collect uh, rags, and call them clothes or shoes, or you collect things together. Or you collect things. Everybody collects things. So you have a collection of furniture in your house. You have a collection of things you hang on your body. You have a collection of things in your kitchen. There is a collection of vehicles that you use for transport. There are so many things. The whole of human life is organized around collections. So that's very simple. So I would now move into the mathematical abstraction called collections, which builds up to affect virtually everything else we shall do. If you find my discussion on set theory too boring, don't worry. It is just for today. I'm not going to do anything more. I'm not going to do that again after today. So, but I just want to be sure that if you don't know it, I carry you along because it's not hard. But if you anything you don't know is hard, whether it is even hard in itself or not. If you don't know it, it remains hard. So let us just see how that will go. When you don't have to understand the codes or programs that are used to illustrate. Whether you understand or you don't understand, type them in. I try to make sure that you cannot just copy my code. You must type. That labor of typing is part of your education and instruction. So I do not put the code in such a way that you can just copy and paste. No, you will have to type. And when you type, you're going to get errors. And your errors, you get punished for your errors until you type the things correctly. You forget a comma, your program will not run. Forget a punctuation mark, your program will not run. You forget a quotation mark, your program will not run. And so many things like that. So you copy the code, execute them through a debugger. I will show you an example as we go on. I hope time permits us to do that. Study the steps they take to deliver their solutions. Extend each one as you deem fit after the codes have run. The first thing is not to try to understand the code, but to try to make the code run. Because if you type the code correctly, the code should run. After the code has run, then you try to understand it. Even if you don't understand it, observe the patterns that have existed in the code, and that may be enough. By the time you know enough patterns, you're already a programmer. Extend each one as you deem fit. Make them your own code. Change things in it so that even if me, that I gave you the code, if I see it, I will no longer remember it's my own code. So be a good pirate. Don't just pirate foolishly. Pirate in such a way that even the person you pirated from does not even know you pirated from him. So if I see the code, I will not even realize you copied my code after you have run it as I intended initially. A time comes after you have mastered all the programs that are used to illustrate. You will begin to complain, this man is not even a good programmer. Once you find yourself talking like that, be careful though. Don't let me hear. It is not a wise thing to say bad things about me when your marks are still in my pocket. When you are gone, you can say anything you like, but not this time. After this time, you can say what you like. Okay, so then you are getting to the second level where you can begin to break the rules. If you find out that you can do better than I have done, that's good. After that, you will use the ideas you have learned and define problems for yourself that you can originate your own programs to solve. Wow, you have mastered the rules. You have broken some of them. Now you are on your way to becoming a master. So we are going to begin by looking at sets as abstract collections. So you will see what a physical collection is like and what an abstract collection is like. When we say something is abstract, what do we mean? How does something being abstract differ from something being physical? What is a physical collection? What is an abstract collection? The set, a fundamental abstraction. A fundamental understanding of sets launches you to many important ideas in mathematics and related subjects. This set of lectures makes you understand, make you create your own interactive environment through Python programming. A play area where you can deepen knowledge about this important concept and the simple rules of abstract set objects that abstract objects obey. It will be shown that basic issues of set look at things as collections in which individual elements have membership. A drawing. Remember, this is a course in graphics, it's a course in modeling. But what is a drawing? A drawing is a collection of simple graphical objects. So it is really a set. It may surprise you to see how applicable the simple rules of sets are to the graphics course you are taking. Every drawing, as you will see, is a collection or set of simple elements. All that makes that collection a drawing is the creation of contact points, alignments, and other relationships one to another. Fundamentally, they are a collection. No matter how complicated a drawing gets, this fundamental law remains. After you have created 3D surfaces and bodies, you see that the laws of set is intersection, union, among others. They are used to create other drawings. The complicated drawings are a collection of collections. This introductory Python lesson uses the idea to teach basics of programming. The table of content here helps you to avoid too many elementary talk if you already understand set theory, which many of you probably do. Much of the material was used, as I told you earlier, for secondary school children. Your feedback will help me to know if you want me to increase the tempo and omit some basic issues. So there's a table of content there that will be useful to you. Okay, let us begin. You can see on the screen, you can see a collection of shells, a collection of pencils, a collection of insects, a collection of baskets and the pots. All these things are collections. And they are sets. When you have a set, what makes a collection a set? You will see the difference between an ordinary collection and an abstract concept of collections, which we call sets. Abstract concepts, numbers. Mathematics begins with abstract concepts. Perhaps the first abstract concept you encounter preschool or in school is the concept of numbers. You probably do not remember when parents made you recite 1, 2, 3, and you were praised for being brilliant or intelligent just because you could count to 20. Accolades for being able to count a particular number, how proud of yourself you were. In school, you were taught abstract operations such as addition, subtraction, etc. It would have been possible to teach this in concrete terms, but teaching them in abstract is by far more powerful, much more powerful. You are told to add 2 plus 2 and get 4. This was your introduction to abstraction because you were not told you were adding 2 goats to get 4 goats, or 2 yams to 2 yams, or 2 naira to 2 naira, etc. You are just told 2 plus 2 is equal to 4. It is time for you to go and apply to 2 goats or 2 yams, 2 pieces of yams, or 2 bags of rice, or 2 whatever. 2 plus 2, no matter what concrete terms you are using, will equal 4. Later in life, you could apply the arithmetic, abstract arithmetic, to many different unrelated things that were not even mentioned when you were in school. Some may not even have existed at that time. That is the power of theory or of abstraction. People think theory is a bad thing. Without theory, this world would be a very boring place indeed. It is theory that gives us the ability to expand and extend ideas far beyond what we would have been able to do. Abstract, now, from the dictionary, is a concept or idea not associated with any specific instance. That is an abstraction. That's a noun. Verb, when you say you want to abstract, consider a concept without thinking of a specific example. Consider abstractly or theoretically. It's also an adjective, existing only in the mind. When you say something is abstract, separated from embodiment. Abstract words like truth. Truth is an abstract word. Justice, without attaching it to anything, is an abstract concept. The fact that something is abstract does not mean that it is meaningless. Things that are abstract can actually still be full of meaning. Abstract concepts, collections, and sets. Another abstract concept, more fundamental than numbers, is the idea of a collection, usually called a set. A deep understanding of the concept of sets prepares you to get a good grasp of mathematics and virtually all other skills for which mathematics is foundational, like programming. It is a more pervasive concept, and it corresponds to things we regularly say in daily conversation. For instance, Dupe was in my high school set. When you say that, you expect us to know what you are talking about. You are talking about sets. What is a set? What is a high school set? It's a collection of students that probably entered or left that school at the same time. It is still a collection. It's a collection of human beings, but it's a collection still. Dupe was in my high school set is a clear, understandable statement to someone who may not even realize that she is into set theory. Surprise, you already know sets. Abstract sets. In set theory, we disembowel sets from the concrete members of real objects that are collected. This, we do not to unnecessarily make things difficult, but to create sets as powerful tools that we will use to explain several advanced concepts later. The abstraction, as we shall see, will help us to define concepts such as functions, limits, continuity, derivatives, integrals, etc. It is a mistake to forget about sets once we complete explaining what they are. The real meat is to see sets in virtually all other concepts we will encounter later. Anytime we are looking at things, more than one at a time, you are back into set theory. Let us begin by looking at familiar sets. We begin reminding ourselves of sets and collections we experience in our daily course of living. If you carry a bag, there's a concrete collection of items inside your bag. That is a set of items. This is a concrete set because the members are both objects you can see and hold. When you dress up, there is a concrete collection of items you hang on your body as soon as you come out of the bathroom. Be they underpants or other briefs, shirts, blouse, pants, skirts, socks, slippers, shoes, wristwatch, bag, wallet, belt, etc. Each person has one collection like this or another. These are sets. In our abstract sets, the only other rule is that members are unique. The fundamental difference between a set and a collection is that for a set, members are unique. Once membership is established, the additional elements are superfluity. They do not give any further information. We want to know the number of unique elements are there. We are not caring about how many of them. We are interested in the membership of our sets. What items are you presently wearing? For instance, Ade is wearing boxers, has a headphone on, wears slippers, shorts, singlet, wristwatch, and t-shirt. So that is what Ade is wearing. Your own set may be different. What are you wearing? That's another set. That is your own set. And your set may be different. Can you list the elements as we have done here for Ade? You list your own elements? If you can list your own, then we can compare your set to the one that Ade has. But make sure you make membership to be unique. So when two items, if you have two identical biros, it's only one of them that is in the set, not both of them. Let us look at items on your menu. You don't have to go to Sheraton or some big hotel before you have a menu. There are some things you fill your stomach with this morning. Could be pounded yam, boli, rice, dodo, yams, eggs, beans, watermelon, mango, egusi, bananas, pineapples, apples, eggs, oranges. Okay. I've listed eggs twice, so I've violated the uniqueness that I was talking about. I didn't see that before. Here are the items in the meals that we had last week. We are looking at the fact that these items are on the menu. As members of a set, it is not the size or the number we are looking at. We are just looking at membership. What belongs, what does not belong to the set. Can you list your favorite meals? How many of your items are named in our set here? These are fruits and vegetables you can find in the garden at my backyard. Can you list what is in your own garden? My garden, you have pawpaw, tomatoes, lemons, bitter leaf, plantains, bananas. Here are things you can find in the toilet. When you visit a public restroom, what is one item that makes your trip uncomfortable if you can't find it? In my toilet, I have a water closet, a hand sanitizer, a waste bin, a hand wash, washing basin, and toilet paper. What do you have in your own toilet? Let us look at the set of items in the kitchen. Can you name the items and other items that are in the kitchen but not here? What is the one item you cannot do without in your kitchen? Your living room, what do you have on your wall? A clock? What do you have? Do you have a mat on the floor? You have a stool? You have a settee? You have pictures? You have AC? Fan? Is a small potted plant. Your own living room may be different. You can list what you have. We can write this programmatically as you have it on the way you have it on the left-hand side is how you write in Python that your living room contains wall clock, rug, side table, wood sofas, air conditioner, paintings, potted plants, ceiling fan. What you have on the left-hand side is a Python line of code. There are rules. You will see there's an assignment there, which is showing itself like an equal sign. I will show you later, it does not mean your arithmetic equal. It has a different connotation. And then you notice that the names of the items are all in quotes. They are not written out on their own. When you have a string of letters in quotes, Python treats them as string. So if they are not in quote, they are no longer strings and they have completely different meaning. So if you want to use them as names, you must put them in quotes. Otherwise, you may be surprised what meanings that Python will attribute to them. Oh, do you like to watch football? I don't, but if you do, are these Nigerian footballers? How many can you identify? You can say Nigerian footballer, you have that list. Well, some of the names there are footballers that played before you were born, so you may not know their names. Is Adam Oshiomhole depicted as a member of this set? Is he a footballer? This is the question of membership. If we use the belongs to sign as membership operator, if we say is A in B, that statement of that something that looks like an E it should be read as in, in. Is A in B? What is A is an element or representative of an element, and B is representing the set. So if B is the set of Nigerian footballers and A is Adam Oshiomhole, is A in B will return false because Adam Oshiomhole was not known to be a football player. Do you know you can write a Python program to ask and get an answer to this question? Here it goes. So you first of all assign the set Nigeria football to an identifier. So the Nige foot there, you can see that one is not in quotes because it is an identifier. You are using it to identify that set. So from that point on in your program, there is a synonymity between Nige foot and that entire set. The programming logic to test for membership is easy. Define the set, create an identifier for the supposed member, assign the result of a membership test to another identifier, check the value of the identifier. You can do this as we have done with a print statement. However, with a proper installation of the IDE, integrated development environment, such as Visual Studio Code, you can get all the information from the debugger without needing to print. So that is one way. What you have on the right-hand side is a full Python code containing 5 lines. The first line, Nige foot, is equal to, the second line, A is equal to Adam Oshiomhole. Everything between lines 1 and 11 represent a compound statement. And the way you know a compound statement is that it doesn't end on a line. Once you begin with that curly bracket, until it sees a matching curly bracket, it doesn't matter how many lines you write, it is still taking it as a single statement. The statement on line 12 is a single statement which assigns or identifies Adam Oshiomhole as simply A. That A, you can see, is not in quotes. So in number 13, we are finding out whether Adam Oshiomhole is a member of the Nigerian football class or set. And the answer will be true or false. And when you say print answer here, the answer here will likely be false because Adam Oshiomhole's name will not be found in any serious list of Nigerian footballers. So you create an identifier for the supposed member. Here we use A. Assign the result of a membership test to another identifier. Check the value of the identifier. You can do this as we have done with the print statement. However, if you have a proper installation with an integrated development environment, IDE such as Visual Studio Code, all the information you need will appear in your debugger. Next, let's look at the set of the things you can travel with. You have a bicycle, a small taxi car, a slightly larger personal pleasurable car, a bolekaja. I don't know whether they still exist. There was a time when that was the only way to travel in Nigeria. Bolekaja. Doesn't matter whether you are going from Lagos to Maiduguri or to Enugu. You will enter a bolekaja, which is a wooden box on top of a truck chassis. You now have modern transportation like the BRT, which is there, and its older cousin, which is a Molue. So, which of these vehicles do you own? Maybe you are an Aristo, I don't know. How did you get home last time you went out? Is that part of the set of transportation items here? The set of transportation that you use? Did you use a drone, a helicopter, an aeroplane, or whatever? What did you use to get home? Or is it bicycle, taxi, car, molekaja, BRT, or Mulwe? You can test for membership. What type of footwear do you like to wear? Here is a set of footwear elements. What are you wearing right now? Use Python to test for membership. What colors do you like? These are the colors of the rainbow spectrum. Can you identify these colors? What's your favorite color? The colors here are red, orange, yellow, plain, blue, indigo, and violet. You can also test for membership. We can have a set of DNA material of pupils from your school. There are several things that can be done with this. For example, imagine that we have the DNA sample of a victim in an accident, and COVID prevents us from checking if that victim came from your school. We may compare the DNA sample to that of all the hair samples in your database and establish if that victim is from your school. So you can see the test for membership is not a trivial issue. That may be a matter of life or death. The test we perform is a membership test. It's a particular DNA matching the one collected in the set. Set of vital statistics. We can collect the weights and heights of all the pupils in a collection of names, weights and heights. Suppose a basketball scout came from you know where, and he wants to meet with Nigerian youth that are up to 2 meters tall. We can investigate that set of weights by checking for membership of weights of a particular height. And then we can now narrow our and then contact them to meet the coach, to meet the scout. We can look at a set of students in a particular class. Observe that this smaller set is a subset of the set of students in the school. Whether we are using DNA, weights, heights, measure, or any other vital statistics, what we want to do is a little more complicated than the test of membership in a single element. We may want to mark another list by asking if members of one list are as tall as a particular height. Now, let us look at the set of positive integers. Back in the first abstraction, you learned the set of positive integer 0, 1, 2, 3, and so on. It's infinite. As you can see, this is just one set. We will later come to look at operations you were able to carry out in the elements or items of this important set. Initially, we will treat it just as a set of objects. Each member is a number. And let us look at another set. Another set is the Arabic numerals. There are 10 of them. All members of post-it, infinite of them, are composed of the 9 basic numerals, which is another set. There are only 10 Arabic numerals, yet the application of simple rules, we may form all the members of the infinite set of positive numbers. The English language has 52 recognizable alphabetic characters. This can be written as the set Alpha Inc. ABCD, ABCD. This set is important because the words that make up the sentences in your letters, essays, books, and manuals are often from members or items of this set. The words in the standard English language are, again, with a set of rules created as combinations and permutations. Permutation is simple an arrangement. That is all there is to the word. There is nothing more. When you say permutation, it's just a big word for arrangement. Okay, so we can arrange and rearrange the 52 members of the Alpha Inc. and we get all the words in the dictionary. These words are in sentences, paragraphs, pages, chapters, books, catalogs, and libraries all over the world. It is arguably an uncountable set of words, yet they come from 52 members or items of the set of Alpha English as defined here. We can see that the members of one set may form the basis of the creation of members of another set. That relationship is not where we begin. We will start, as we shall see, with more basic relationships. Still stay with the common English language. There is another important set. This one contains 52 elements of Alpha Eng, and the English characters are 9 numbers, Arabic numerals. The complete alphanumerical set is this: A, B, C, D to Z, A, B, C, D to Z, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what can happen. The set is useful in programming. We use them to construct the names of identifiers, disk files, and other things, as we shall see. As we have seen, the concept of set is simply a formalization of our natural concept of connectors. Mathematics uses a logical discipline to allow us to organize this concept that results in an orderly superstructure. When we are done, it becomes mind-blowing. Yet, each step is so simple that even a child with little distractions can fully follow. The next step we will see is to examine the most elementary relationships that exist among some of the sets we have been looking at. To emphasize the simplicity of the relationships we will consider, let us first remember that there are complex relationships we will not immediately consider. For example, the set of numerals are generators of the set of positive natural numbers. The set of alpha ing generates the entire set of known words. We are not pro tempore concerned with these kinds of relationships. We will look at simple transparent relationships between these sets first. Take a closer look at the set. The alphanumeric English contains all the alphabetic characters as well as the Arabic numbers. Those two inner sets are disjoint because they do not have anything in common, but they are both contained by the outside set. Similarly, every element in numerical Nom Arab is also an element of alphanumeric Eng. We express these ideas as alpha Eng is a subset of alphanumeric Eng. Similarly, Nom Arab is a subset of alphanumeric Eng. Equivalently, we can say that alphanumeric Eng is a superset of Nom Arab. It's also a superset of Alpha English. The previous slides define the word subset and superset. We can formalize the definition immediately and say that if A is a subset of B, any element that is in A is necessarily in B. If the set A is a subset of B, then we say that A is included in B. Equivalently, we may say that B contains A. As the figure shows, alphanumeric Eng is a superset of Nom Arab and Alpha Eng. They are both contained or included in that set. There is no element they have that is not in the big set. Is there a relationship between Nom Arab and Alpha Eng? Observe that there is no element of Arab Eng that is also an element of Alpha Eng. The converse is also true. In this situation, where two sets are disjoint, we say they are disjoint when they don't have things in common. So the elements of Nom Arabic and Arabic Eng are disjoint sets. The absence of common elements between two sets is what defines their set relationship as disjoint. The same idea is expressed in saying that their intersection is empty or it is the null set. The intersection of two sets is a set containing all elements that are members of both sets. If an element does not belong to either set, it is not in the intersection. If an element is a member of only one of the two sets, it is not in the intersection. To be in the intersection, the element must necessarily have membership in both sets. There are members of the APC party from your village. The set of these members from your village is the intersection of APC party with the set of inhabitants from your village. Even if I'm a member of APC, I may not intersect unless I also come from your village. If I am a village, I may not be a member of APC. I am also not in the intersection. To be in the intersection, I must be in both. The intersection of two sets is of itself also a set. In an intersection, it is an intersection because the way its membership is defined. Every word intersection occurs to express this relationship with two sets to which the elements that have membership are also part of. This is natural after all. The fact that I'm in the intersection of APC and your village does not stop me from belonging to the vigilante group or even Omotayo. The statements we have made so far are formal expressions of relationship between elements of different sets. These relationships are expressed in such words as inclusion, containment, subset, superset, etc. Mathematically, they are ways of saying the same things in a shorter form. When you say them in the shorter form, you are saying the same thing. We introduce symbols to help us reduce the words used again and again so that we can gain parsimony in expression. For a given set S, if an element A is among the elements in S, we use the mathematical shorthand to write A belongs to S. We can also write that several elements are members of the same set using the same shorthand. A, B, C, D belonging to S. Similarly, non-membership can be expressed as A is not in S or A, B, C, D not in S. Containment and inclusion. For two sets, if every member of set S is also a member of T, it means that set is contained in T. In mathematics, we write S is contained in T in this way. If in addition, every member of T is also in S, then the two sets are equal. If, however, the members of T are some members of T are absent from S, then the subset relationship is strictly so. Hence, we write, in this case, S is a subset of T. Containment and inclusion. The last relationship can be interpreted as S is included in T or T is contained in S. The example we have looked at previously, we can easily see that alpha eng is contained in alphanumeric eng as depicted in the diagram. Consider the set of the first 20 positive integers, pos int, the first 20. Compare this to the set of Arabic numerals. These two sets have the first 10 numbers in common. We can form a set out of these two elements and call it the intersection of the two sets. The intersection of the two sets is a set containing the elements that are common to both. If one of the sets is the same as the intersection between the two sets, then we have a containment in it. For instance, in numeric Arab, the intersection with alphanumeric eng is the same thing as numeric Arab. That shows that numeric Arab is a subset of alphanumeric eng. If there are no common elements, then the intersection is an empty set. The set that are disjoint. The sets of alpha eng and numeric Arab is disjoint, and their intersection is the empty set. Important results. If A intersection B is A, in which case all the elements of A are present in B, it means all the elements of A are also in B without the elements of B necessarily part of A. Then B contains A, or A is contained in B. If the intersection of two sets is zero, the empty set, in which case there are no elements common, the sets are disjoint. The converse is also true. If the sets are disjoint, there are no common elements. Their intersection is the empty set. This can be taken as a definition of relationships disjoint between two sets. So we can talk more about intersection here. You can read what I'm writing there if you are getting too boring now. We will come back to all of this when we start programming shortly, because I'm just building the fodder for our programs. Uh, these are issues in the union, defining what is union is. These are rules of union, the number of elements in the union and intersection, and then some of these are formulas of and commutativity issues you have in set theory. You read this because I'm going to turn everything here into computer code. I just want to use very simple examples that we can program and understand. Mathematical and other operations of sets. Okay, so we now begin with a simple program. You can see the set of positive integers and the set of numerical Arab numerals. And now we want to check if 12 is in positive integer. And then we can print it. So looking at this pattern, you can check for membership of any element in the data set. Shall we? So we can also check the intersection. This is the way you write it in. These codes I'm writing now are simple codes in Python. For instance, this code, the code here is easily explainable. The first line is assignment of this is set to an identifier. The second line is also another assignment to another identifier. And then you now have an if package there, which checks whether an element is inside a particular set, and to check and print out whether it's there or not. Looking at this pattern, you can check for membership of any element in either set. Shall we? I hope you know you have started programming. All you need to do now is to type the codes I've done and run them. And you will not understand everything about it. For instance, the assignment of set to an identifier, you already understand. So that one is not a problem. And then you can see what the test is. You see that some words change color. We would learn about that shortly. And then you see what it takes to print. You can print a quoted string. That means that what you have quoted there will come out in your print system verbatim. Looking at this pattern, you can check for membership for any element in either set. You can do it in the other way, and you will see that A intersect B is the same thing as B intersect A. So those are things you can do. Look at this code. We use Python to calculate that the set is the intersection of post-int and Arab numerals. We call it intersection, intersect. We then try to find if 12 is in the intersection. We can now go ahead and do your own test for other elements by amending the program to do what you want to get done. If you have never programmed before, and today is your first time, now you are writing programs. So you type what we have in. If you understand 50% of what is there, that's a good start. After some time, you'll be understanding 100%. And when you go back to do your review, you will know everything there is to know. So you learn by practicing, and you practice leading to learning. So we're on page 60 now. From page 60, we are now going to be considering programming fundamentals. We have also spent close to 50 minutes in this class. So what I'm going to do, I'm going to give you 20 minutes break. And in the 20 minutes break, I will check if there are comments on the chat room. And if there are none, remember that I'm going to give you grades based on your participation. So better do some things in the chat room so that you can earn marks there. And but please make it reasonable, make it useful. So we're going to start from page 60 when we come back from break. I'm giving you 20 minutes break. So we're going to begin again at 10 past 11. So you can go, but like I said, I'm going to check the chat room and I'll see whether some people have asked questions there. So now we are starting from page 60. On page 60, we are now going, after building the foundation of basic set theory, which is basically to remind you what you ought to already know in sets. We will now use that and try to understand some basic Python tokens and how Python language allows you to write programs. We concretize a few elements, 3 concepts in Python programming, so you get you started with sets and a simple concepts. Before delving into this, two important issues. One, I say it again, you do not have to understand everything in Python code to obtain useful results. When you do not understand some things, take note of the patterns. Sometimes the patterns in the programming code will be sufficient to get useful results. Full understanding is our goal, but it will not happen immediately. Refusing to move until you attain full understanding is not optimal. I repeat that. Refusing to move until you attain full understanding is not optimal. That's not the best way to learn. You can learn by not fully understanding but going ahead. But you must type in the code, you must run the code, you must get the results that are expected. That is step 1. Step 2 is now to try to go back down and see whether you can understand what's going on. Okay, so here we are going to start with some, we are going to understand some of the tokens of a program. For instance, the program you have in the top right corner is a program containing 1, 2, 3, 4 lines. It contains 4 lines, and in these 4 lines, there are elements of the program that I want to explain. Look at the first statements on the right. The equality sign you see in these statements do not carry the same meaning as your arithmetic equality. So we need to explain what that means. They are called assignment statements. So our program right now consists of 4 assignment statements. Statements that are assignment statements contain 3 elements. An expression of value at the right-hand side, an identifier on the left-hand side, and an arithmetic assignment separating them. Read it like this. Compute the expression or the value on the right-hand side. Assign the identifier on the left-hand side as a reference to the result. So an arithmetic assignment, look at the schematic I gave you. There's an expression on the right-hand side. There's an identifier on the left-hand side. And then you construct an identifier. You construct, the way you construct an identifier, you construct, all the identifier begin with an alphabetic character. The other things may not be alphabetic. They can be the positions can be numerics or alphanumerics. So what we are saying is that you could not write this is equal to you cannot place this post int on the other side. It is not correct. So you remember that if it's an equality, you can put what you have on the left on what you have on the right. In an arithmetic assignment, what will be on the left must be a single assignment identifier. It's an assignment identifier. Like you have on the left, you have post int, a numeric arab, alpha low, alpha up. All those things can only occur on the right. So identifiers can only occur on the right, and expressions can occur, so on the left, expressions can occur on the right, as we have seen. In this particular case, what you have all on our left are always sets, but it would be more complicated than that later on. It could be other things. And now, what constitutes a set? The first set, you have numbers, and you can see the numbers are not in quotes. The second set, you also have numbers. The third set, you have letters that are in quotes, and so on. So all those are 4 arithmetic assignments. That's what you have. And so from this point on, you do not need what is on the right-hand side because their value is already contained in the identifier. So if you want this whole set, you just take its reference value and that reference will give you everything you have in that set. Now, identifiers, assignments, and sets. The arithmetic assignment here are simple because there is no expression to evaluate on the right-hand side. Instead, in each case, we simply have a packed set with its elements as we have seen previously. The statements therefore simply assigns the sets on the right-hand side to the properly named identifiers on the right-hand side, on the left-hand side. Once such a reference is established, any of those identifiers beyond that logical point in the program refers to the assigned result, that is the packed set in this case. That is, any time from now, when you mention pos int, what it means is what is being packed into it. That is the only meaning it has. Now, I talked about properly assigned identifiers. Properly assigned identifier. What is a properly composed identifier? When is an identifier correct? First thing is that thou shalt not use a keyword as an identifier. There are certain things in the Python that are called keywords, and they must not be used as identifier. That's rule number one. You create identifier names as you like. Any name is accepted, except that you must start the name with an alphabetic character. What contains after that, yeah, you can use alphanumerics after that. You create identifier names as you like by selecting elements to form a single word, and it must be a single word, no space, from the set of alphanumeric integer, like alphanumeric English. The first set must be a member of the alpha ing, that is, must be alphabetic. Any element of alphanumeric ing can occupy other positions. Use as many characters as reasonable. No real limitations as how long they can be. The identifiers you use are case sensitive. So pos int in the four different ways we wrote it are different identifiers. So you must be consistent, because if you write it one way and you write it another way, it takes them as two different identifiers entirely. You are not allowed spaces or special characters in the names of identifiers. Use what will be you will be able to remember, as you will need to recall the identified result or object later, but it must not be a keyword. So the question is then, what is a keyword? Keywords. In the full program you are to explore here, there are several other words that are of interest. These are keywords. Well, I won't give you a complete list yet. You will get it later on. True is a keyword. N is a keyword. False is a keyword. For is a keyword. If is a keyword. Else is a keyword. Break is a keyword. Print. All these things are where print is, well, let us treat it as a keyword for now, but you will see why it's not a true keyword. But these are things you shouldn't use. And keywords are to be used only in the context of their use. There is nothing, you cannot use them any other way. You cannot use them. Identifier, you are free to use identifier as you like. A keyword has a predetermined meaning in the Python code. It may only be used in that context. The numbers in the sets are numeric constants, and the quoted letters are string constants or string, str. So when we have a longer program now. Here, the punctuator or the assignment statement is used doing what it can do. Now, when you have a statement like the fifth statement, and you say alpha low dot union of alpha up, that is how you say alpha low, which is a set, is union with alpha up. That's how you write it. The dot there is being used in a specific context. It's not part of the identifier, and it is what picks the union command to be used in the context of alpha low. That's how you write it. If you don't understand it, just type it first of all and get your result. After some time, you will see a pattern and you'll be able to use it. Now, true or false, which we have here, is being assigned to the value of true. So what you have on the left here is an identifier, and what you have there is a keyword which has a particular meaning. So you are saying that the identifier on the left-hand side is presently having the value of true. Now, the statement we have here contains the statement that starts from the for and ends. This whole thing is a compound statement. It has for, if, and else sections. The for section, which begins with a condition ending in a quotation, is going to go in loops, and the if there is a compound statement with the else. If this thing is true, this statement will be executed. If it is not, this statement will be executed. That's what will happen here. The for here ends in the break. The for it's also again containing an if statement. The indentations here are not optional and they are strict, and they can only happen in one way only, and nothing else but in one way. You will get to know what they are gradually. But what you have to do now is to type these statements, obeying all the indentation, obeying everything until you can get the result. Any error it gives you is because of your mistake, because every program I give you is a tested and working code. Identifiers. Apart from keywords, another kind of word like token of interest are identifiers. These are examples of identifiers: post integer, numerical, Arabic numerals, alpha low, alpha up, alpha edge. All these ones are identifiers. In your own programs, you create the identifiers primarily to store and reference values, results, or of expressions or computations. And because of that, when you use that, they must appear on the left. When they appear on the right, their value will be put to their location. So if you want to multiply something you've already identified by 2, whatever result is in it, you multiply it by 2, you put the identifier's name there. But when an identifier is receiving a result, it must appear on the left-hand side alone. That's how it receives a result. So this again is another program. The need for literary strings. Anytime you want to use a literary string in your program, the following rules must be observed. Place your strings in quotes. If you do not, the Python interpreter assumes that what you have written is either a keyword or an identifier. The only way you can separate a keyword from an identifier is if you place a string from an identifier is if you place the string in quotes. The identifier refers to a place in memory where something has been stored. You are allowed single or double quotes as you like. Just be consistent. You cannot, for example, open with a double quote and appear it with a single quote. Obey the rules and your code will be correctly interpreted. See some code again on the top left here. Observe that what follows the colon ending the first statement. Everything pertaining to that head is indented in a single indent forward. All statements indented this way form the block of the for loop. Everything indented away from the for is part of its loop. The if there is also a compound statement. Anything indented away from the if is part of the if. Anything indented away from the else is part of the else. So that is how this statement makes sense. So that means that the if as well as the else belong to the for, whereas the true false is equal to true here belongs to the if, and the true false is equal to false here belongs to the else, and the break here also belongs to the else. So indentation away from a keyword is what determines containment. Further observe that the if-else block is also another block in this loop. Here is the meaning of the code. Pick elements in the post int one by one. Each time check if the element also belongs to alpha numeric int. If so, assign true to false, or assign true to true false. If not, assign false and stop using break keywords. Stop using the break keyword in the looping process. That is all that there is to this statement set here. So let us we have just been introduced to some few things. We have been introduced to keywords. We have been introduced to keywords. We have also been introduced to identifiers. We have talked about literary quoted strings. We have talked about numbers. And then we have now talked about compound statement. A compound statement does not end on the line. It has a structure. The for has a structure. The if has a structure. The else has a structure. For instance, an if cannot appear on its own, but an else must always follow an if. You cannot have an else without an if, whereas you can have an if without an else. An if statement can occur all alone, but an else must follow an if. So when an if and else follow each other, you talk of the if-else block, and it will be arranged there. The statements between them can be many. In this case, you have one or two statements, but if blocks can be very much more complicated, and they can contain other blocks themselves. And that is how the thing becomes complicated. Now, we are going to look at another kind of Python token, a set. The set collection as defined in Python is very close to the one defined in mathematics. Very close. They are not identical, but they are almost identical. Each element in the set is unique. If you add an object already in the set, it simply overrides a previous member. So it doesn't increase. Adding what is already in the set to the set does not increase the elements in the set, because the elements in the set must be unique. Simple set relationships such as membership, subset, number of elements can be found easily. Python represents its set by surrounding its listed comma-separated objects with braces. That is how Python creates a set. It starts with braces, ends with braces, and the things inside it are separated by commas. And if it is strings, then they must be in quotes. If it's numbers, they don't have to be in quotes. There can be other elements that can be members of a set. A for loop can be used to move objects. A for loop can be used to move from object to object. And when you are moving from object to object using a for loop, it is called an iteration. A list that has this property is said to be iterable. A list that you can visit the elements in it by a for loop, by iterating a for loop, is called an iterable. So a set is an iterable object. There are objects that cannot be iterated. They are not iterables, but a set is an iterable. So if I talk about a collection being iterable, I mean that it is possible for me to go into the number of elements there and look at them one by one using a for loop. That is called an iterable. Three other Python collections are useful. They are lists, tuples, and dicts. All of them are also iterables. They are not sets. So set is not the only game in town. There are other things other than sets. We will introduce them one by one. The three, just like sets, are also iterable. We will introduce the others later. Currently, we introduce the list collection. In the case of the list is represented with brackets, square brackets instead of braces. In the case of the list, you are allowed to have duplicates or multiplicities. It is also iterable. So if you want a collection that contains repeats, and you want those repeats to be there, then what you need to use is not a set, but a list. A list can contain other things, can contain non-unique items, and the list is also iterable. We are now going to just go into some interactive examples. I will go through about 5 or 6 of them, and this lecture will be over. Please, what do you do with the list? What do you do with the examples? All the examples in the entire slides I've given you, practice everything and send me questions. I'll have questions in the chat room when you come back. So you not be satisfied until you have run each program. Run the program, run the program, then try to understand it. Run first, understand later. Run first, understand later. Run first, understand later. Don't wait until you understand before you run. I've already written the code. It's already working. I know it will work. What I want to give you is practice. Several examples, guiding principles, several examples and exercises will be given subsequently. We will ask a question. If you can write a Python program to answer the question, go ahead and do so. Compare your answer to the one given. I will write the code to answer the question. If you can do your own code before you look at mine, good. If you can't, don't worry. After a time, you'll be able to do so. Make amends to your code if there are errors and try again. It's a good practice to attempt to write your own code first. If you are unable to do so immediately, don't be discouraged. Practice makes perfect. As you go along, you will become better. If you fail to write a successful program, make sure you practice by typing in the solution provided and learn the proper lessons before attempting the next exercise. If you can write a code first, it will increase your ability to understand faster. So that is why I advise that. So you try that way. So what we are going to do here, beginning from the list of items Ade is wearing, we want to check if the list of what you are wearing is a subset of Ade's own, or if it's a disjoint set with Ade's own. Recall that if the intersection of A and B is an empty set in which there is no elements in common, the sets are disjoint. And if a set is empty, the number of elements in it will be 0. So we can check. So for instance, in Ade's case, there is singlets, there are shorts, there are t-shirts, there are slippers, there are headphones, there are wristwatches, and there's a wristwatch, and there are boxers. Toby's has 2. Just name yourself and put in the list the things you are wearing. Put your full list there, and we can try the intersection with you instead of with Toby, and then you can print. Toby is wearing, what Toby is wearing is a subset of Ade's, or if they have nothing in common, you say they have nothing in common, then, or there are some things that are unique to both. So that program, write that program and use your own name instead of Toby to check whether you are the same thing with Ade. And here, if you have never programmed before, now you are programming. You are programming. The issue that we are raising is simple, but if you can solve this simple case by writing the program, it is just additional effort to do other things with programming. That's it. You've started. Exercise 2. Beginning from the list of items Ade is wearing, from the intersection between Ade's set and yours, demonstrate that if any two sets S and T, for any two sets S and T, the intersection operation is commutative. That is, S intersection T is the same thing as T intersection S. Apart from printing these results, create identifiers and assign them. Use the debug facility to check the results instead of printing them to the terminal. I will, by the time we get to exercise 6, I will go through it with you, and I will open my own Visual Studio Code, and I will run the code through it the way I want you to be running all these codes. I will use that as an example, as a hands-on example. These are the reasons why teaching online is superior to teaching face-to-face for me, because there are things that I'll be able to do now that I may not be able to do in a face-to-face situation in the class. Beginning from the list of items Ade is wearing, we are now in exercise 3. Beginning from the list of things Ade is wearing, find the intersection between Ade's set and yours. Demonstrate that for any two sets, the union, not intersection in this case, the union operation is commutative. That is, S union T is same thing as T union The other case, we tried it for intersection. Here now we are proving it for union. The exercise 4, we are going to prove the set identity that the number of elements in S plus the number of elements in T is stating as the number of elements in S union T plus the number of elements in S intersection T. So that is what we are going to prove here. And that is what the code on the top right is doing. Using the relationship between the SN on chemist menu, we demonstrate the above mathematical relationship between sets. Note that the Python equality operator is the double equal sign rather than the single equal sign. So when you really want the arithmetic equality, when it comes inside Python, you have to double it, because the single equality is used for assignment. It's not equal. But when you want to check for equality, you have to do the double assignment. One easy error is when you use the single equality when you wanted the double, or vice versa. And the Python, like any other programming language, is not going to forgive you. It's going to punish you for making that mistake. If you make that mistake 2 times, you'll be punished 2 times. If you make the mistake 10 times, you'll be punished 10 times. If you make the mistake 100 times, you'll be punished 100 times. So until you give up. So it's not going to forget and pardon you. It doesn't pardon. It doesn't forgive yours. It doesn't forgive your sins. It's not God. So Python is not God, does not forgive sins. So it only punishes sins. Nothing else will happen. The next thing is the dictionary. We are introducing the dictionary. Aim, given 2 sets, find the membership of items in one set. Find if a membership in one set is repeated in the other. We use dict to achieve this. A dict is another kind of collection. In a dict, there is a key that is matched to a value. We can create an empty dict by simply an empty brace pair. An empty brace pair. We create a dict. So to add values to a list, we simply take the name of the list and assign. I mean to add values to a dict, not to a list. Suppose we have a set of authors available in our library. Suppose we have a set of authors. Now, we have another set of authors we want to read. Our exercise is to take each item in my list and check it against the author's library set. The set is used to match the availability of each item in our set. So let us look at it here. You have the first one, you create a set of authors. The second one, you create another set of authors you want to read. And then on line 16, you create a dict called my dict. So you look at the compound statement here for authors in my list. If author is in author's library, you are going to use the my dict indexed with author is available. So you take the author and you use it to index my dict, and you read it as available or not available. So the dict is going to give you the availability or non-availability of the authors in my list. It will tell you whether it is available or not available. Again, the issues that I've discussed will not all be clear to you, but type in this and run it first. Once you run it, we will have more discussion in the next class on it. I think we have gotten to the one that I'm going to play with you I will fire up my Visual Studio Code now, and I will run something that looks like exercise 6. Aim, given 2 sets, find membership of items in one set in the other. We use this to address it. This is another kind of collection, and so on. So you see that we have the first list as science grades, the second list are Nobel laureates. We want to check whether the how many of the which of the one is in the other, because there are areas of there are people who are science grades and Nobel laureates, and there are people who are Nobel laureates and are science grades. There are people who are in one and not in the other. So what you want to check now is where one particular where there is uh, intersection, and you are going to use a dict to check whether somebody is a Nobel laureate, and when somebody is just simply great and is not a Nobel laureate. So somebody might be a great scientist without necessarily being a Nobel laureate. Let's see. And I want us to also use the Venn diagram. In your program, you are going to create the Venn diagram. When you create a Venn diagram, you create the Venn diagram programmatically. You will see that uh, you have one set, you have another set. Then you want to create the intersection between the sets, you want to create the union between the sets, and you want to demonstrate graphically how this appears, the way you were taught in school. But this time, you are going to be creating them programmatically like this. So your Python, as you have installed it, may not work immediately like this, because there are some libraries that are not natural with Python that you may have to install. I will try and show you how to install those libraries in this class. And one of the libraries is called the matplotlib. Another library is the matplotlib underscore ven. It's a different library. Uh, the fact that you have installed matplotlib does not mean that you are going to have matplotlib ven. It is the matplotlib ven that allows you to be able to create Venn diagrams inside Python. And this 1, 2, 3, 4, 5, 6, 7, these 8 lines of code is going to create the Venn diagram you have there. And in the Venn diagram you have, there are Nobel laureates, and the yellow ones are the people who are Nobel laureates alone. The red one are the people who are great scientists alone. And the intersection between the two, there are 9 of them that are both Nobel laureates and they are also great scientists. So those are the things that you can do here. So by the time you are able to create this Venn diagram, you've already attained some distance in your coding. So let me just do this, something like this now. And I'm going to run my code. So what I did here is slightly different. I have here the same thing from my matplotlib, import ven2, and so on, and ven2 cycles. Did I do that here? Oh, no. Okay, so I have that. And then from matplotlib, import pyplot as plt. And you have the science grades here. The list I have here, I just typed this in before the lecture today. So they may not be exactly the same as what you have in the code in the slides. Instead of science grades and Nobel laureates, I have science grades and Italians. From line 9, you have a set of Italians: Galileo Galilei, Alessandro Volta, Enrico Fermi, Amerigo Vespucci, Leonardo da Vinci, Michelangelo, Nicholas Evangelista, and so on. These are scientists. Some of these scientists are also uh, great. Some of these Italians are also scientists. So what we want to do is to do a Venn diagram of these two sets and see which one belong to which, and which one are where is intersection, and then you show that, and then you do some things with it. So the way I run it here is that I go to the run and I say start debugging. When I say start debugging, it runs until it gets to a breakpoint. It runs until it gets to a breakpoint, and it marks the breakpoint. Let's see, has it run? Yes. So the question is, how do you create this breakpoint? All you need to do to create a breakpoint is that you see that as you are moving your cursor on at the beginning there, you will see something light coming on. And if you click on it, for instance, I can create another breakpoint by clicking I can add a breakpoint. I can add a breakpoint there, and I can add a breakpoint. So I have two breakpoints now. Breakpoints are where your program will stop if you are running it, and then you can now step in or step into the program or step through the program. And on the top left corner, you are going to be getting a lot of important information. For instance, at this point now, it's telling you there are variables. It's telling you that it already knows PLT to be a module and some other things. You will see that as we move on, that will be changing. So by the time we move to the next thing, it has already seen that science grades. It has already taken the identifier science grades, and it has given it has taken note of all that it contains. That science grades contains Charles Darwin, Alexander, all those things. It may not be in the order you have put them, and it has assigned some labels internal for its own internal work to them. So as at line 9, it only knows science. It doesn't know Italians yet. So by the time I either use F10 or step over that next statement, you see what has happened now is that it knows about science grades, which we have. It also knows about Italians now, and it has given it knows about that set. It knows about the set, the Italians. It knows about the PLT identifier, what it contains, that it contains matplot, pyplot, and matplot library, pyplot. It has given you those information. So the next time now is going to execute the Venn diagram here. Is going to do that, and it's going to come and say, so let us see if we iterate over that. It's going, okay. It has done the plotting. It has done the plotting, which is what you see here. Let me make it bigger so you can see it. The plotting here is not as nice as the one I did before. I can change what is happening here. I can change the colors. Let us say, let me quit this. And then so that is showing the plot. So it has been this statement here forces it to make a plot. And number 15 forces it to show the plot. The fact that Python has plotted doesn't mean you will see it. You have to call the plot show method for you to see, and the program will stop there until you tell it to go on. And then the next on 16 is going to create an intersection between the science grades and Italians, and it is going to pack that into the list. So if I step into that one now, after stepping into that, you will see that there is another variable here now called int list. It's only 3 of the Italians that are great scientists: Enrico Fermi, Alessandro Volta, and Galileo Galilei. Only those 3. And then, for instance, I don't like the color light blue here. I can say red. Let me say I use red there, and I use green here. And after this, I want to rerun the program. So I want to rerun the program, start debugging again. When I start debugging again, so I'm waiting for the program to run onto the first break point. Yes, it has got to the first breakpoint by highlighting it. So I can debug, leap over to the next to number 9, then leap over to number 12, and then it will continue until it's now. You can see what is happening here just by my changing the colors. You can see what is happening here. You can see, if you look carefully, you'll see that there's 20 here, there is 3 here, there is 7 here. So it's telling me there are 20 grades that are not Italians, and then there are 7 Italians, and then out of the 7 Italians, 3 of them are great scientists, and it has labeled them scientific great Italians. just the way I've asked it to do. So these are the things for the first time. I am not expecting you to fully understand the codes, but I'm expecting you to fully type them in and run them. And let me tell you where problems may arise. Where problems may arise is that you see that your code, your program may not have matplotlib or matplotlib. Here it is. There is an error here. It seems to be an error here, but there's no error because it is running the thing correctly. But don't worry about that for now. I will correct that in my own program. But your matplotlib may give you an error. Your pyplot may give you an error. And how to solve that problem is to come here. For those of you who have only one Python interpreter, it's very easy. You can go to the bottom left side of your screen and you will see the Python version you are using. In this case now, I'm using version 3.12.2. So if you have more than one, you can click there. If you click there, all the, like here now, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 8 Python versions. And there is, so I know it is 3.12.2 that I am using. So it will let you know which one you are using. And you can go to view. If you go to view and you open a terminal, this is the terminal here. And when you get to that terminal, you can install the Python. You can install the Python. You can use this kind of code to install the Python. To install to Python the library that is missing. You must install that library. Let me just see. I used. You probably have to do this if you want to install. I don't know whether you can see this. Pip install matplotlib-ven will install the ven library. If you want to install the matplotlib library alone, just say pip install matplotlib. It will install it onto your current working Python. So that is the change you may need to make in order for your Python to be able to run this code. If it is not running the code, I hope you'll be able to find that easy to do. It's just pip install inside your terminal. You can get to that terminal by clicking view, and you can say view terminal. It will give you a terminal that you can do pip install on. Once you're able to do that, your code should be running. I've taken you all the way to exercise 7 or 8. But I want you to not only get to exercise 7 or 8, run through the entire examples, and I will move faster with your Python, because what I want to do with Python is to use it to teach FreeCAD. So you will continue learning Python throughout the time. So this one, the first 2 lectures on Python are just to get you going. And most of the time, we are going to have exercises and examples in your graphics. We have just 5 minutes to the end of the class now, and I know you need to prepare for your next class, either by moving to the place or whatever. So I'm going to release you. But if you have any comments on today's class, don't forget to leave it in the chat room, because even after today's class, I'm still going to visit the chat room and see what comments you have made. If there are comments, please make them. And your marking yourself as attending the class is not taken as any serious comment, okay? So don't just come and be giving me your matric number that you are present. That is not what I want. I want to see that you are active in the class. And I told you, those of you who attend the physical class, that I'm going to reward you for attending the class. Up to 5 points will be at stake. Some people will get 0/5, some will get 1/5, 2/5, 3/5, 4/5, and 5/5. It's going to depend on the quality of your participation. And like I told you, asking a question and answering the question count for the same. So you don't have to be brilliant or know the answer to questions before you come to class. No. So that is where we are going to have it today. We're going to stop here. And I hope we see you again tomorrow. Tomorrow we are going to start our first FreeCAD class. Seriously, tomorrow. So have a nice day and see you tomorrow. Bye-bye.